questions. So, number 15 on the review. Bobo bots eats DC. Do you remember what all that stood for? Bigger on bottom, bigger on top. Exponents are the same. What's the O in Bobo?
0.
Yes. Yeah, y equals 0. What's the S in bots? Slant. And what's the DC? Divide the coefficients. So there's your quick review of Bobo bots eats DC. Let's go ahead and answer number 15, which the following is true. It has a hole. How do we know where a hole is? Factors top and bottom. I don't even have any factors top, so there's definitely no hole at negative 1/2.
Divide the coefficients every. Like, what would you be trying to find?
That would give you the horizontal asymptote when you divide the coefficients.
Okay.
If the exponents are the same. The graph has a horizontal asymptote of y equals negative 1/2. Well, I mean, I think I see where the negative 1/2 is, but is this a Bobo, a bots, or an eats DC problem? It's Bobo, because what's the degree of the bottom? And the degree of the top? 0. So that's a Bobo problem, which means the horizontal asymptote is y equals 0. So 2 is not true.
So it's only slant asymptote if it's bigger on top.
Correct.
The degree, right?
The degree is bigger on top, yeah. The graph has no x-intercept. Let's see. X-intercept means set y equal to 0. What makes a fraction equal to 0? The top or the bottom? The top. So what does this mean about x-intercepts? There aren't any x-intercepts. So 3 is true. Only 3.
So with the Bobo, it's always 0. I thought you had to plug into something. Where is that? Which one do you have to plug into the original equation?
For a hole, you got to plug in. Once you cancel the factors that cancel, you plug that into what's left to get the y-coordinate of the hole. That might be what you're thinking about.
Probably.
Because Bobo is always 0. Bots, you got to divide, so that's a little bit longer. That's a pain. Eats DC is not too bad because you just divide the coefficients.
Is there like a boss example on there?
Any other questions on 15?
For the x-intercept, the 0 and the 1, what do you do with those? Do you multiply them?
Well, you're setting 0 equal to 1, but that's not true. So there is no x-intercept.
Is there usually no x-intercept?
No, because usually we have factors in the top. And so we would set whatever's in the top equal to 0 to get our x-intercepts. There's a question about a slant asymptote. Let's see, where would that come up? 19 and 20. What makes 19 and 20 different?
One has 3
In the-
one can synthetic, one can.
Okay, which one can use synthetic?
The top one.
Synthetic. And this one you'd have to long divide. So which one would you like to see?
No, synthetics. It's long. Synthetics easier.
Synthetic's easier.
So much easier. Long.
We'll do the long. It's also posted in the other video, so if you're stuck here watching, go watch the other video to see the long divide. So let's look at the synthetic division one. So 3, 7, negative 2. And then be careful, if you're dividing by x plus 4, then the number you're putting out there is negative 4. Copy down the 3. 3 times negative 4 is negative 12. 7 minus 12 is negative 5. I really could stop there because I know the remainder is throwaway. So y equals 3x minus 5 is the slant asymptote. So number 32. What should I do first on number 32? Factor it. And I think I'm going to factor out that negative to make life a little easier. All right, are there any holes? Any holes in this graph? So, yes. What's the x-coordinate of the hole? -3. How do I find the y-coordinate of the hole? Plug it into what's left. So -3 minus 5 over -3 minus 3. It's a lot of negative signs to keep up with. 8 over -6, -4/3. How about vertical asymptotes? Any vertical asymptotes? X equals 3. Horizontal asymptote, that's Bobo bots eats DC. Is this a Bobo, a bots, or an eats DC problem? Eats DC, good. And so what happens when we DC? Divide the coefficients, we get -1. Y-intercept, we set x equal to 0. So -0 minus 5 over 0 minus 3. -5/3. X-intercept would be set y equal to 0. So 0 equals -x minus 5 over x minus 3. Again, what makes a fraction 0? The top or the bottom? The top, so I don't really care about the bottom. So if x minus 5 equals 0, then x equals 5. Alright, let's see if we can put all of that information on the graph. Vertical asymptote, or no, hole first. -3, -4/3. X equals 3. Y equals -1. We got lots of stuff on this one. -5/3, that would be -1 2/3. And then an x-intercept of 5, 0. So on the left-hand side, I feel pretty good. I got 2 points already. I suppose if you wanted to plug in x equals 2, you could. It doesn't have to be perfect. Now, be careful when you say that. Obviously, it needs to. This stuff needs to be perfect, and this stuff needs to be on the graph perfectly. But filling in the graph after that does not have to be perfect, because I didn't check to see when x is 2 exactly what the y value is. Only 1 point there, which is enough. I guess if you wanted to check x equals 4. I will, just so we remember how to check an extra point if we want one. It would be -4 minus 5 is -1. Over 4 minus 3 is 1. Well, that turned out okay. So 4, 1 is a point. And I guess it's still not perfect because I didn't check all the points, but I know that side looks pretty good. So all all of the pieces. And there is definitely one that looks like that on the test, where you fill out everything and then put it on the graph. Only one where it looks like this. There are other questions, like the review, where it asks individual pieces, but there's only one that find everything straight through. What's that? So that would not be multiple choice. That's going to be lots of points there.
Sorry, how did you graph the negative 5 stuff?
So I know that negative 5/3 would be the same as negative 1 2/3. Right, just changing fractions from improper to mixed number. Back in 6th grade. My 6th grader had homework on that last week. Not with negatives, though. Number 12 on the review. Partial fraction decomposition. Remember, this is the Jeopardy game of the two denominators had to be x plus 4 and x minus 4. And what we're looking for is the numerators, a and b. I don't know. Let's see. So let's multiply everybody by x plus 4, x minus 4 to wipe out all our fractions. So on the left, I get 8. On the right, this is the step that people mess up. So it would really be helpful if you guys were watching so you don't mess this up tomorrow, Thursday. On this first term, the x plus 4's cancel. So what is left standing with x, or with a, excuse me? X minus 4. And what's left standing with b? X plus 4. I don't understand why that's the missed point, because to me it seems pretty straightforward there, but that's getting from here to here is one of the mistake places. What's a good value of x to pick? Yeah, negative 4 and 4, because that will wipe out some things. So a times 0 plus b times 8. That's why we picked 4, to wipe one of these out. So we get b is 1. We do negative 4. A times negative 8 plus b times 0. So a is negative 1. And then just be careful, make sure you put the right number over the right fraction. Over x plus 4 is a, so negative 1 over x plus 4. Over x minus 4 is b, so 1 over x minus 4. Number 30. Remember, we changed it from a minus to a plus to make it work out. Move the 3 over. X plus 27 to the 3 halves equals 8. Did you mess up 11 minus 3? Okay, let me finish the problem, even though you now know what 11 minus 3 is.
9, so I was like, nothing cubed is 9.
Yeah. Well, that's actually a good point, because this is a no calculator test, so you're going to get numbers that work. So you're right, if you get 9 and then you end up trying to take the cube root of 9, it's like that doesn't work. Well, maybe you messed something up prior to that. So it's a really good way to catch your mistake when you know your answers are supposed to be nice. So x plus 27, 8 to the 2/3. Okay, I'm a little short on space. Let's see if I can do this in my head here. Which number is the root, the 2 or the 3? The 3. So I want the cube root of 8 is 2. I said I was going to not show work, but the cube root of 8 is 2. 2 squared is 4. So x is negative 23. On number 26, find the x-intercepts x plus 5, x minus 4. And so, yes, the x minus 4's cancel. And there's a reason we taught the steps in the order we did. Like, if it's a whole, then you can throw it out. There's a whole at x equals 4, not an x-intercept. So you have to be careful. If you'd have just factored the top and said, well, zeros come from the top, it must be 4 and negative 5. No, because there's a hole at 4. So that's a really good question. X-intercepts means set y equal to 0. So there's only one x-intercept for this one. That would be negative 5. So at negative 5, 0. You're welcome. Okay.
For 18, I got 18.
Which of the following statements about that is true for 18? All right, so let's factor it and see what happens. So x plus 7, x minus 2 in the bottom. So I've got a hole at x equals negative 7. I'll start looking at the choices here. The graph has a hole when x equals 2. No, there's a hole at x equals 7. That one's not true. The graph has, negative 7, thank you. The graph has a vertical asymptote at x equals 0. Yes, x equals 0 and x equals 2. So that's a true statement. It's not the only vertical asymptote, but there is a vertical asymptote there. The graph has a vertical asymptote when x equals negative 7. No, because that's a hole. So that one's not true. The graph has a 0 when x equals 5. That would be true. So you're right. That should not happen. We wouldn't. That's extra cruel and mark all that apply. So that's a mistake on our part. But B and D are both true on number 18. You're correct. Good question. All right, I think we've seen enough